let's try and put everything together that we know about buoyant force. So buoyant force exists whenever an object is placed inside the fluid, any kind of fluid, whether it's gas or liquid or plasma. Let's talk about the most common fluid, or the most common liquid for that matter, water. If we have something placed inside water, water being a liquid occupies a certain amount of volumes. And so whenever we stick something inside water, that object that has volume will displace a certain amount of water, and it will actually displace the same amount that it occupies itself. So if this object is occupying some volume and displaces fluid, in this case water, will try to push it out. And it will try to push it out applying an upward force, which is called buoyant force. In some cases, objects end up floating if buoyant force equals force of gravity. So like in this case that I'm showing you, force of gravity equals buoyant force in magnitude and is opposite in direction, and in that case this object will just stay in equilibrium and at rest. If we are dealing with something like a helium balloon, which is in another type of fluid, in gas, in air, and air is greater in density than helium. So in this case, buoyant force is actually going to be greater than force of gravity on the balloon. So in this case, the object is going to end up moving upwards. And then in another example, we can have an object that is not displacing enough fluid and ends up with the gravity mg actually greater than buoyant force. And in that case, it can be in the process of sinking, or it can already sit at the bottom and there will be some normal force going upwards. But whatever it is, there is always force buoyant force, or force of buoyancy. It's always upwards, and according to Archimedes, buoyant force, in any case, whatever the case may be, whether the object is floating, whether it's sinking, whether it's just rising or in equilibrium at the surface, in any case, buoyant force will be found as the weight of the displaced fluid. So that's your mg, where m is the mass of the fluid that is displaced. All right, so look at these two cases. In these two cases, we have two objects. One of them sank because, as you see, buoyant force is less than force of gravity. In this case, our buoyant force can be found according to Archimedes' principle as density of the fluid times volume of the fluid times g. And volume of the fluid, as you see, is the volume of the entire object, because the entire object is in, and the object can only displace the amount of fluid that equals its own volume. So I can actually rewrite this as buoyant force equals density of the fluid times, if you will, volume of the object times g. In this case on the right, the object is floating. It's at equilibrium. It's not sinking. It's not flying up like a balloon. It's just at equilibrium. So these two forces, the force of gravity and the buoyant force, are equal to each other. So I can say that force of gravity, which is mass of the object times g, equals buoyant force. And buoyant force, according to Archimedes, is mass of the fluid times g, which is the weight of the displaced fluid. We can actually get rid of g's and can say that the mass of the object actually equals the mass of the fluid that it displaces. And in this case, I cannot say that the volume of the object equals the volume of the fluid. They are not equal. Only part of this object is under fluid. So see, only part of this, and only this volume that equals this part that is under, will be equal to the volume of the displaced fluid. In any case, buoyant force is present, and we know how to find it. In the case on the left, it will be found by Archimedes' principle, and then over here it will be found as equal to the force of gravity in magnitude. So whenever you're trying to find the buoyant force, there is one question that you will ask yourself, and that is, will the object sink or float? And in order to figure out whether it sinks or floats, you will compare the two densities, the density of the fluid and the density of the object. The object will sink if it's denser than the fluid that it's in, like in this example. I'm only showing two forces even though there should be three. There will be normal force upwards from the bottom of whatever that container is. But since we're just comparing the buoyant force and the mg, I'm going to show you that mg is in fact greater than buoyant force. So buoyant force, again, in this case, is going to be found by Archimedes' principle. Buoyant force equals, again, this right here is mass of the fluid. This is going to be mass of the fluid times g, which is, as Archimedes said, the weight of the displaced fluid. And again, in this case, since the entire object is inside the fluid, the volume of the fluid equals the volume of the object. So we can rewrite formula buoyant force equals a density of the fluid times volume of the object times g. If the object is only floating, it's not completely submerged, and it's not sinking or going upwards, we can say for sure that these two forces, the force buoyancy and force of gravity, are equal in magnitude. In this case, the fluid is actually denser than the object that is in it. That is why only part of this object is submerged. So buoyant force equals the weight of the object. We rewrite the buoyant force as weight of the fluid that is displaced, and weight of the object is on the right. So then we can get rid of g and end up with just the two masses. Mass of the fluid equals mass of the object. And then just figure out, instead of masses, we can write densities times volumes. And so, as you see, the density right here, the density of the fluid is greater than the density of the object. So, on the opposite, the volume of the fluid that is displaced is going to be less than the actual volume of the object. Only part, this part right here, that equals the volume of the displaced fluid. So if we were to find this volume of the object that is submerged, we would need to find the volume of the fluid right here. And that is going to be demonstrated in the next example. So that's it.